You see this game? Yeah, this is what I made last year. Not gonna lie, at that time, I thought it was revolutionary. The controls, the physics, everything. This year, I decided to finish this game once and for all and publish it. But everything feels off. This is not what I imagined at all. I know the UI is bad, but the code is terrible. Everything is a mess. Items are not loaded, some functions are not working properly, and the codes are jumbled together like cooked spaghetti. It's barely functioning. That's why in this video, I will transform this game into something better, cleaner, and most importantly, be playable to a certain degree. This game is made using Pygame as a game engine. I know some better alternatives, but I decided to use this game engine for educational purposes. I may have some experience with Pygame, but based on the previous project I had made in my entire life, I decided to use this opportunity to learn more of what I could. I started this development by copying most of the code I had made in my previous project into this game. If you don't know yet, I made my first game based on this project. You can watch it on my previous video. I copied all the improvements I made in my previous project into this game. For example here, the screen menu, the core game logic, the game state, entity, save and load function. It made this development much easier compared to copying it from the previous version of this game. Let's start with the menu screen. If you look at this code here, I first create a list of buttons I want to make. Then, I create a container to group all the buttons. To create the button object, I iterate the list and create the object based on its label. I also set the action based on the button label so I don't have to create a separate function for it. Here is what it looks like, drawing on the screen. Next, onto the core game logic. Before that, I created several functions that can handle the button on the screen menu, like new and load game, setting, and credits. Some of the functions are empty, but let's put them here for now. The first thing I did was create a game class that will handle the game. This way, whenever I click on a new game or load game, it will create a new object rather than have two separate functions. I also add game loop functions to handle the game state. If you look at the code here, the game loop is called first before anything else. If I click the new game button, the menu screen will return the action into this loop. The game loop will set the result into a new game. This will call the new game function and create a new game object. This also works similarly with the load game function. The difference is that I send the data into the object. In this game object, I set the logic whether or not there is data sent into this object. If there is data, it will load the data and create objects based on that data. If not, it will simply create the objects with its default value. Now, let's look at the UI object first. I made two UI classes, the button and the container. These classes handle all the drawing and action without me creating them one by one, especially the button, where it will return the button using labels as action when clicked, reducing the action needed to handle the click button. Before I created the entities for the game, I first created a general class object called stats to handle all the attributes for the player, enemies, and items. I know that this method will reduce the amount of set attributes I have to write for all the game entities, but this method also creates unnecessary attributes for something they do not need. This class also handles methods like draw, apply physics, climb position, and rotation angle. This apply physics function is where the magics happen. You can see here in this gameplay, the player and enemy are somehow moved in a more dynamic flow. This function handles the acceleration and drag movement based on weight or mass. Let's take a quick look in this profile class. This class creates three UI sections for the minimap, inventory, and player profile. Minimaps and inventory do not yet exist, so let's place it for now. The player profile will draw the player name, image, health, shield, and level. I made a simple animation for the bar using the ratio method, so the player knows how much longer they can still fight. For the player object, I add additional attributes like level, experience requirement, upgrade points, and bullet list. The player draws on the center of the screen with a rotated angle based on the mouse position. The player moves using this simple function. When the key is pressed, it will apply a thrust based on a player movement speed. Then the apply physics function will be called. This function also handles simple shooting logic, where the player clicks on the left mouse button. We call the shoot function and create bullets, just this code shows. I also added a simple damage calculation. If the player takes damage, it will check whether or not the player has shield left. If not, then the player HP will reduce, otherwise the shield get reduced first. Lastly, this level up function will handle player level up, adding points and increasing level requirement. For the game to be playable, enemies are a must. To make it more interesting, I create two types of enemy, melee and range. These two types of enemy are created using one object class. The enemies are drawn with their shield and HP bar attached to them. The bar is drawn based on enemy condition. If the shield is more than 0, then it will draw a blue bar. If less and equal than 0 and HP are more than 0, it will draw a red bar. The enemies spawn at random location with random behavior. For the behavior, I added simple logic to this update. If the enemies are melee types, the enemies will charge towards the player. If the enemies are range type, the enemies will move towards the player with some distance, stop and then shoot. If the distance is less than what it desires, it will stop shooting and move away from the player. Interesting, right? Lastly, I added function for the enemies to take damage and increase the difficulty based on time. To give the player a chance at survival, I added two types of recovery, health recovery and shield recovery, which will spawn at random locations. I made the recovery boxes to only heal 5% based on max value, just for the simplicity. The game will not complete without upgrades for the player. I decided to create a roguelike type of upgrade where it gives the player 3 random choices for the upgrade. I categorized them based on rarity, like common, uncommon, rare, epic and legendary, and created them in a JSON file. For now, I only create common and uncommon upgrades. Then, I loaded the JSON file into the upgrade class. To make the player be able to choose upgrades, I draw several cards based on card quantity, which is 3. The card contains the detail of the upgrade, like name, rarity, quantity, and effect. I also made the card change color depending on their rarity. Grey for common, green for uncommon, blue for rare, purple for epic, and yellow for legendary. For the upgrades to show at random based on rarity, I created a list of weight and calculated it in this function. I put all my initialization, pathing, encryption, save and load functions in this config file. To make the saving so much easier, I created a custom serializable class for my game. I could use the default Python saving method, but I found out it was unreadable to humans and less secure. I don't know if that is true because I consulted with ChatGPT about a better method to save and load data, and it suggested that I created a custom saving method myself. I used this method on a previous project, but in this method I made some improvement. Rather than save data in a list format, I saved them in a dictionary format. You can see the example here. To secure the data so that the player can't modify it as they please, I added encryption and hashing on the saved data. This way, the player can't read without permission, and if they somehow are able to read and modify the saved data, the hashing check will give an error that the data has been tampered. You can see the detail here how the functions interact with each other. That's all I have to share. I am very satisfied with what I did in this project, and it looks much better and cleaner. Making this video made me realize there are some ghost functions and variables, but don't worry, on the next update I will make more improvement. I learned quite a lot, more than previous projects, and I hope you also learn from this too. I may use a little bit of help from AI, I hope you don't mind. If you enjoyed this video, like and share with others as well. You can also subscribe to my channel and get more updates on my projects.